Example 2. Trusses are frequently used to support roofs on buildings. The simplest type of roof truss is a triangle. Find angle beta to the nearest degree in the truss shown in the figure. All right, so it's good news that we have an illustration provided for us. This is a roof truss, so you can kind of imagine, just so you can kind of understand what this is. If you imagine a bunch of these put together, like I'm just kind of doing the same shape here. So a whole bunch of these put side by side, okay? Like way more than 4, but you can kind of imagine it's forming your roof, okay, of like a house or a building. So that's what a roof truss is, okay? So we just have a single truss here, and for this particular one, we are given all 3 sides, okay? So if you follow my cursor, this side is 16 feet, this side is 13 feet, this side is 20 feet. 2 of the angles are labeled. This is angle theta, this is angle beta. What we need to find is angle beta to the nearest degree, okay? So this is obviously not a right triangle, okay? You can see there is no right triangle in this truss. So because it's not a right triangle, you have to use either the law of sines or the law of cosines to solve this oblique triangle. Okay, it depends on what case this is. So that's the first thing we need to do, is figure out the case so that we can decide between the law of sines and the law of cosines. Okay, well, what are we given? Like I said, we are given all 3 sides. So this is the side, side, side case. Okay, what have I been telling you? How to remember the 2. If you are dealing with sides or SAS, that's when you need to do law of cosines. Okay, so this is all sides, so this is going to be law of cosines. Okay, if we go back to page 2 and we look in the box with law of cosines, remember law of cosines has 3 different statements. Okay, it does matter which one you are going to use here. Okay, so let's go back to the triangle, and I know we've got theta and beta. Let's do some naming here, okay? I'm going to put names on these guys, okay? So I'm going to call this angle A. I'm going to call this one B for beta. This is angle C. So if I go straight across from angle C, this is going to be side lowercase c. If I go straight across from angle A, this is going to be the side 13 feet. That's going to be lowercase a. And then if I go across from angle B, this is going to be lowercase b. Side B is going to be 16 feet. Okay, if I label it this way, then it's going to be a lot easier to use the law of cosines to figure out which formula you need to use here. We're looking for angle B or angle beta or angle B. Okay, so let me write that here. We're looking for angle B. Okay, if I go back now to the law of cosines and I look at the 3 statements, only one of them has angle B involved. So this is the statement I need to use. Okay, so I'm going to go ahead and write this one down. Okay, so our formula is going to be that b squared is equal to a squared plus c squared minus 2 times a times c times the cosine of angle B. Okay, this is what we're going to use. Okay, so we can go ahead and plug into it, okay, or we can solve for the cosine of B, okay, since we're after angle B. Okay, that's what I'm going to do here. Okay, I'm going to solve for angle B, or I'm going to solve for the cosine of B. And then once I have that, I'll plug into it. Okay, but if you want to go ahead and plug in for lowercase a, b, and c, then go right ahead. Okay, it's up to you about how you want to do this. Okay, all right, I've highlighted cosine of B in yellow. I need to isolate that term. Okay, so b squared, a squared, and c squared are just numbers, as is negative 2 times a times c. So just treat it like that. If we want to isolate the thing in yellow, we're going to move the a squared over and the c squared over. Both of those guys are positive, so we're going to subtract them from both sides. Okay, so that's going to tell us that b squared minus a squared minus c squared is equal to negative 2ac times the cosine of B. Okay, so we're almost there. Okay, I'm still trying to isolate cosine of B. It is being multiplied by -2 times A times C. That's just a number, so we can divide it off. Okay, so this is going to tell us how to compute the cosine of B. Okay, so we need to do B squared minus A squared minus C squared over -2 times A times C. Okay, so I'm going to come over here and do this. Okay, so I'm going to reverse the order of the equation here. So I'm going to put the cosine of B on the left. That has got to equal to B squared. Okay, so look how I have this labeled. B is 16 feet, so I'm going to do 16 squared minus A squared. A is 13, so 13 squared minus C squared. C is 20. Okay, so we're going to get that. That's the numerator. And then I've got to divide by -2 times A, which is 13, times C, which is 20. Okay, this is going to give us a number for the cosine of B. So we're going to go and punch this in. I'm going to put the numerator in first. So this is going to be 16 squared minus 13 squared minus 20 squared. Okay, and so we're going to get this number. Actually, that's a pretty nice number, -313. Okay, and we're going to divide that by this quantity, -2 times 13 times 20. I'm just going to go ahead and pop that in. When I divide here, I'm going to hit my division key to divide. I'm going to put the entire denominator in parentheses just to be careful here. So we're going to divide by -2 times 13 times 20. Okay, and so this is going to be the quantity on the right. Okay, you need to use the full decimal expansion for accuracy. Okay, so I'm going to write it down, 0.60192307, and then we've got 69. Okay, if you start rounding, it is going to mess with the angle. It's going to start rounding the angle, and we want to be exact. We want to be as accurate as possible. Okay, so this tells us that the cosine of B is equal to this decimal. If we want angle B, we need to take the cosine inverse of both sides. Okay, so I'm going to go ahead and do that. That will free angle B from the cosine. Okay, whatever you do to one side, you have to do to the other. So let me just write this in for your notes. Okay. Again, you absolutely have to use the entire decimal expansion. Okay, so on the left side, the cosine inverse and the cosine will cancel, leaving you with the measure of angle B. Okay, so this is what we need to pop into our calculator. Okay, we already have that decimal expansion in the calculator. We just need to compute its inverse cosine. Okay, so let me write this down. And remember, if you want an angle in radians, then your calculator needs to be in radian mode. But if you want an angle in degrees, your calculator needs to be in degree mode. It's up to you. We were told to express the answer to the nearest degree, so we need to make sure we are in degree mode, which we are. So if you're not, go ahead and change it. And then I'm going to do the inverse cosine. You can either type the decimal in, use all the digits, check it to make sure you typed it in right, or you can do second negative sign down here, and it will call up the previous answer. And here it is. Okay, so I'm going to go ahead and write this out. It's 52.9922476. Okay, that is in degrees. If you do not put the degree symbol on there, then that is a measure that's a radian measure. Okay, so you've got to put the degree symbol. Again, we were told to round to the nearest degree. So angle B in the truss, which is angle beta, okay, it is approximately 53 degrees. Okay, and we are done.